Hello, everyone. Welcome. I'm Igor Alekseev. I'm a partner solutions architect on AWS. And yes, we'll talk about how to build generative AI applications on AWS today. So first of all, MongoDB and AWS are partners. MongoDB, yeah, we have some our team folks, partner team folks here. MongoDB is part of, actually, let me see, this is better. We have, MongoDB achieved many, can you achieve competencies? Obtained competencies. And they are part of many of our programs. Recently, generative AI competencies they reached, we have obtained. We have many joint integrations, the Bedrock, Private Link. Private Link is super popular. Actually, quickly, who is here on AWS? Just to know, okay. Who is on Azure? GCP? Okay, yeah, that's interesting. So no GCP almost. Yeah, I will try to introduce services that are people who are not familiar with AWS. Yeah, recently we achieved generative AI with MongoDB. That's a competency. Now, MongoDB Atlas on AWS, and these are architectures that people can build with MongoDB Atlas. And think of these, it's a busy slide. I call it shock and awe slide. You can build many of the architectures. Think of this as quadrants. You can grab from top left your data ingestion mechanism. From bottom left, you can grab your compute, let's say Lambda. Let's say from top, we grab Kinesis Data Firehose. And in the middle, of course, you have MongoDB Atlas. So we're ingesting data. We serve our compute of Lambda. And we're interacting with the data stored in MongoDB Atlas. That's an architecture. You can extract your data maybe into S3, train the models. Then you have also machine learning components. So the main point here is many of these applications are possible. You can just combine, mix and match. And you can create your own architectures. Now, of course, this is all about generative AI applications. So just quick introduction of our generative AI stack. So think of it as we have these 3 layers. At the top, what we call generative AI applications. So these are high level. They are configuration mostly, little coding, as little as possible. Anybody can do it. A lot of things are abstracted away from you. You don't need to worry about which model it is, which foundation model. You don't need to worry about embeddings and chunking, etc. Actually, who is here, like in terms of kind of skills, who is here a software developer? Who is a DBA? No, I'm not a DBA. Okay. Who is a data scientist? Okay. Data scientists are afraid to admit they're data scientists now because of generative AI. Executive managers. Okay. All right. So yes. So the top layer is towards more analysts, maybe developer, but mostly with configuration. Now, the middle layer is where Amazon Bedrock. Oh, yeah, actually, in the applications, you'll hear the top layer will be like Q for business, where you basically bring your own data. You will have ability to ingest it. It will create the bot for you. The bot will start answering questions based on the data you've brought in. You don't need to worry about prompts. You don't need to worry about the model. You don't need to worry about anything. The bot will be up in 20 minutes. You show it to your boss. You get a promo. Done. But if you want to customize something, if you want to do some coding, well, if you need to have an application where you have more control of the application, then you kind of drop on the lower level, and that's where Amazon Bedrock sits. It's a serverless service with which you interact primarily via APIs. You make API calls, and you send some data to a model will respond. And then when we go to the lowest level, it's more for people who have the most control. And that's where data scientists kind of live. Because if a situation, sometimes you need to train them an additional model. And sometimes you want to control the training process, and you want to choose your own silicon or some instances with whatever specific GPUs. So we have Trainium, which is our own custom chip, inferential used for inference. this stack, the last layer of the stack, kind of sits on top of the traditional AI/ML stack that we have, where you have SageMaker, and you have, we have our own GPU, CPU instances, EC2. This is where you train the models. So let's look at the traditional AI/ML application. Application meaning here, that application that uses machine learning, no generative AI first, just to contrast. And we're going to use Canvas SageMaker, SageMaker Canvas. This is a kind of AutoML type of application. I don't know, have you heard of AutoML? If not, it's like, it was a motion a couple of years ago. Basically, you give it a data set, you roughly describe the problem, it will train it for you. So this is the easiest to use for non-data scientists. So here's what the total architecture will look like. So we have users interacting with the application at the mobile, or we have to change Flex device sync because MongoDB is changing their support for that. So users interacting either through the mobile application or through the web-based application. Data is sent to MongoDB Atlas, data is stored there. Then in the application layer, we make a call to the, let's say something's changed, we make a call to the database. We make a trigger will get invoked, and we need to call a Lambda on the back end to make inference based on the data that has arrived. Maybe we calculate in some kind of score or some kind of, basically we enrich the data with results of model inference. Great. Now, if we want to keep our model up to date, we need to extract data from the application somehow into this 3 bucket. In this case, we're going to use Canvas. We will build a new version of the model. We'll deploy that model to a SageMaker endpoint. So this is traditional application using AI/ML. And then there's some variations of these, but you interact with the model, you enrich your data. Maybe you make some decision based on data. Now, RAG. RAG became popular. Everybody heard about RAG, right, here? Great. So but just a reminder, even though I asked, I'm going to still talk about it. Just a reminder, this is like the quick flow, right? You have your data sources. You have to break them up into pieces. You need to choose an embeddings model. You need to choose your vector store. Then you need to have your kind of like application layer. And that application layer will interact with the vector store doing semantic search. You've heard MongoDB talking about how their vector store, they support semantic search. And the user will send their user query. That semantic search will be done on the database. And then that results of that search will come back up to the application layer, and they'll be used as a context to interact with the language model. And in the process called a prompt augmentation, where you just have your own prompt, but it's some context. You put them together, send it to the model, get a response. Great. So this is RAG. Everybody knows RAG. Now, when you come to implementing RAG, there is a challenges here, right? So you have to manage multiple data sources potentially to create embeddings for large volumes of data. Whenever the changes are happening, you need to implement incremental updates. Otherwise, your semantic search will not provide the results that you want. There's coding involved. You're all developer. You love coding, so that's fine. Not a challenge. And then you also have to scale your retrieval mechanism. So you have to make, well, in MongoDB Atlas, you get it out of the box, but you have to think like how many hits you're going to have. MongoDB has now support for specialized search node for semantic search, so that's good. And you have orchestration. Now let's look at first if you want to do it, if you want a full control of the process. So you're at the, remember the layers, you're at the lowest level. You want to control the model that you choose. So let's say you're doing it with SageMaker Jumpstart. Jumpstart is a product on AWS. It's a machine learning product, but they have like a catalog of pre-built models. Then you can select that model, select a model that you like. You can experiment with it. Typically, these models come with a notebook. You can basically run through the notebook. It will deploy the model to a model endpoint. And there will be example of prompts. You will experiment. You maybe change something. You deploy it to SageMaker endpoint. And then you will start writing an application, interacting with that SageMaker endpoint. In terms of models that are available, it's basically publicly available foundation models. So there's a variety here. You see Cohere, Databricks, or any custom models you can bring. That's your choice. You're not restricted here. You're at the lowest level. You're almost not restricted by anything. Yeah, so this is the same process. Let's look at what the application approximately will look like. So you have roughly 3 components. You have a UI, UX section where how your user interacts with the application. And it can be anything. In this case, I chose the compute Lambda, serverless compute. Lambda will be interacting with an endpoint. And SageMaker Jumpstart is what I was just talking. That's where you chose that model and you deployed it to the endpoint. And Lambda will be using, let's say, semantic search in Atlas and will be retrieving data. So overall, the architecture is serverless, very simple. A lot of components are missing. But this is what it was like 2 years ago, approximately. People started experimenting, but still, even today, you start like this. This basically, you interact with the model, you provide results, and like you shovel them back into your UI. Prompt is fully customizable, model is fully customizable, semantic search, you do it with Atlas. What am I glossing over here? The no ingestion. You don't see how the embeddings are making it into the database. Well, that's what you need to think first. Next, you kind of have to think, how do we add them? And I'll show you in a couple of next slides. Let's look at another architecture. Let's say you want to fine-tune the model or build your own model. In that case, you have to think where you're getting your data. Let's say maybe your data provides enough, your application provides enough data for you to build a model. Then all you need to think about is extraction mechanism from MongoDB Atlas. So there is a $out operator in Atlas to write to S3, the object store. There are some other mechanisms you can do. Glue, it's like a ETL service on AWS. And then you need to talk to data scientists to either train the model or fine-tune the model, because this is your full control. You're extracting this data, and you want to tune the model because you're not happy with what's out of the box. And then once you tune the model, you deploy it to SageMaker endpoint. And next, let me just quickly. On next slide, let's say, how do you generate embeddings? So initial load, you can just write a giant batch process to just plow through all data you have, generate embeddings. Or you can also have real-time. But then after initial, you need to do like incremental. How do you do incremental? You need some kind of mechanism to know when things are changing. So in this particular case, one of the examples is Event Bridge. So in Atlas, Event Bridge is a serverless event bus. So when something is happening in a database, like insert update, or something is happening to the data, there is a special trigger you can configure that will trigger Event Bridge event. In this case, when the event is triggered, we will invoke Lambda. Lambda will then get let's say, some description got updated, that text description. Lambda will send it to SageMaker endpoint to come up with to get the embeddings. The embeddings then will be stored in the MongoDB Atlas database. Now so we were talking about Jumpstart, and you provision the models yourself, you interact with the SageMaker endpoint, you scale the SageMaker endpoint. How did Bedrock come into play, that middle layer of the architectures? These are kind of the tenants that were driving development of the Amazon Bedrock service. We were trying to address, well, not me, AWS was trying to address concerns from the customers, or which models they want to use, how they can move quickly, how they can keep data secure and private. So Amazon Bedrock simplifies the choice, simplifies the way you customize your application, helps you with integration, and provides security and governance. So we consider it the easiest way to build applications. You have access to leading foundation models in a single API. You can privately customize your own data. So you don't need to worry about the data leaking out. You're customizing it privately. It's a big concern for a lot of customers. You get performance from the infrastructure. You're not managing infrastructure like just now. I was talking about SageMaker Jumpstart, deployed to endpoint. You need to figure out the scalability. You need to configure scalability of the endpoint. You do not do it here. our infrastructure underneath is managed by Bedrock. And there is also data security and compliance. There is also capability to have agents. And you can extend the power of the FM through retrieval augmented generation. Now, the models are available in Bedrock. So, of course, there's a bunch of models available from Amazon. Now, these models are curated. So this is a selection that AWS decided is what we want you to interact with. You don't see a lot of models here. Like, for example, there's a popular embeddings model from Nomic. You don't see it here. You'll have to go to Jamstart. But these are the models we kind of chose. They are good models. You can work with them. Claude is a very good one. So there's a whole family of Claude models. So you can move between different models based on your needs. So Haiku is the fastest one. Sonnet is kind of balanced approach. Opus will give you the highest quality answers. On Amazon side, Amazon Titan, basically our models based on, actually the next slide is about Titan. So we have text embeddings. So that's a model to generate embeddings. There is a light for summarization. There is multimodal embeddings as well if you have mixture of images. And there are some new models for image generator. Now, Bedrock constantly adding new features and service, and I'll highlight several of them here. So there is evaluation of the model. So it's an important step because first thing you need to know, will this model work with my type of user queries and with my data? So there's a place to kind of look at the models, how they're performing. Now, how do you work with Bedrock? It's similar actually process. There is a playground on the UI on the console. You can go and choose an FM, a foundation model. You can fine tune it if you want. But then you would start sending prompts to the model. Just on the UI, actually, you can type and see what responses. You can paste some text. And you look at the response to see if you like it. And in terms of architecture, well, again, it's very basic architecture is very similar. There is no more, the difference here is you don't see a SageMaker endpoint anymore. There is no deployment of the model process. You just make a straight call to Bedrock API, and then you say, I want to interact with this model, and here's what I'm providing you, the prompt, the augmented prompt with the user context. The rest, the front end does not change because that's what the application does. Compute, of course, that Lambda will be different. There will be different code to interact with an API. Context search, semantic search, that the semantic search itself code does not change. You still need to have embeddings. You still need to have all the things there. Let's look at more complex architecture. This is an architecture we did specifically for Anthropic, but we kind of wanted to do a little bit more. And actually, it's overall trend. So if you look at the previous one, that box, Lambda box, is kind of simple. There is more complexity in the orchestration, and that's where agents are coming out. So in this particular bot, we created this architecture to imitate like a customer service center. And we have a knowledge base, which is an atlas loaded up with some data. There is embeddings there. But what we have created, we used long chain agents. So you'll hear agentic systems. That's currently the most popular. Basically, these are the pieces of code. In Lambda, in code, it actually is a function with a description that the model decides to use. And based on the user query, the model may decide to use a direct lookup within MongoDB Atlas, or lexicographical search, or you can do semantic search. That decision is made by the model, not by you. You're just providing function description, and you say, oh, I want to create this agent chain, which will be using this model and these tools. And so it's a bit more complex in terms of orchestration of what's happening inside. With agents, like for programmers, it's actually very hard. You going from a deterministic world where you control the flow explicitly to a probabilistic world which user query may be answered this way or may be answered that way. And you have some control, but not exact control. So, interesting, how do you do unit testing then if your responses like fluctuate like that? But Data scientists have been dealing with this for quite a while. They know models provide non-deterministic responses. Sometimes it's this, sometimes it's that. But for programmers, it's a mindset change. I think I covered everything here. Yeah, ingestion flow I'm not showing here. It's a separate process and similar to like before. Anything that is interactively added should be done via triggers, or you have a batch to do it. Now, Bedrock has some capabilities for prompt management because prompt management, creation of the prompts, tracking what kind of results they're given, it's kind of process in itself, so they've added. There is also new features to control prompt flows. It's a little bit small, but you can, that orchestration I was describing we did in the code, Bedrock has it in a visual form where you can construct the flow. Again, you control, in this case, it's a little bit more deterministic. But there's another concept called knowledge bases. And MongoDB is now, it was one of the four or five knowledge bases that you can select in Amazon AWS console. So knowledge bases where it's almost RAG as a service. It supports a full RAG workflow. Again, in your application, you will interact with it via APIs, but you don't need to worry about ingesting the data. And I'll also show how it's done in a second. And you automatically it automatically will convert text embeddings. Basically, actually, it will take source of your data, S3, or there's some couple of sources. They will be adding more sources. And then you will specify, I want to use this embeddings model. It will take the source and chunking strategy. Chunking is like how document is broken up into pieces. You can select several chunking strategies. It will generate the embeddings and store them in MongoDB Atlas. You don't need to do anything. And you can provide source attribution. So roughly how it works, users provides a query. It goes to the Bedrock. Bedrock will use a knowledge base to do the search. But you're just calling one API. Here is my user query with what are we getting. And then a prompt is constructed, and using some large LLM, you provide a response. So MongoDB is available, like when you select, there is a default, but there is a custom selection you can provide. You can select MongoDB, supply access your cluster credentials. It will connect to cluster and will retrieve the data. Now, agents I was talking about. So sometimes the specific tasks can be done by what is called an agent. It's like a function. It will basically execute. It can search knowledge base. It can observe the results. Meaning model. An LLM will observe the results and decides that I can use another agent to do something else, or maybe that result is good enough to give back to the user. So when you build an agent system, you basically select a foundation model. You provide some instructions, basic instructions. It will select relevant. You construct the agents, which are may be hooked to data sources. They don't have to be hooked to data sources. For example, I had an application where all my agent does is constructing a giant prompt, because user query can be small, but my prompt has to be big to fulfill that query. And agents can do the functions. Some brand new features, code interpretation for agents, that agents can generate and execute code. Super scary. I haven't tried it yet, generating and executing. There is a concept of memory retention where agents, when you have interactive system, and it's what traditional machine learning could not do, interactive system, where you keep some history of interaction with the user and then use it to respond to this next question. This kind of capabilities are only possible with generative AI architectures now. And in this case, this kind of memory retention can be available for agents to help with the future actions. What is the architecture? Not much different. But what's happening here, you have the same UI box. You have the front end, or whatever your application does. You have your compute. Now, because we're using knowledge bases, your starting point is S3. So knowledge has to be an S3. So whatever documents you want to underpin your knowledge, it needs to be an S3. Then Bedrock will break it up, ingest it. Another additional point here, where you need to create agents. Agents could be doing lookups in MongoDB. They don't have to do lookups, but let's say in this case, like in Anthropic reference architecture, we did lookups. Yeah, Lambda will still interact with Bedrock after all of these changes, still interact via APIs, nothing changes here. And then agents are whatever your specific domain, they can do actions, either update data in the MongoDB database or retrieve in a certain specific known way or pattern where you don't need to use semantic search, you use lexicographical search. Or maybe if you're in the context of like say it's a banking application, you just do direct lookup of your customer information. Important part of generative API applications is Amazon is a feature in Bedrock. It's called guardrails. This is something like if you look at our simple application, we never talked about what happens. We generated a response, we send it back to the user, but what if it was not a very good response? Like what if it was using bad words? In order for that to kind of accommodate for that, you need to have some sort of guardrails. Sometimes it could be another model. You train another model to kind of look at your output and do some kind of scoring on that. You might also want to train another or insert that process of scoring your own output to see the quality of the responses. And sometimes you might want to ask a user to rate the responses selective and then start slowly accumulating a label data set and to see what's, first of all, that will help you improve the application because you will know what the users are getting. Without it, you're flying blind effectively. Users are using the application, you don't know if they like the responses or don't. You can introduce a thumbs up, thumbs down, yes, but 5% will click, maybe. But with a custom model, evaluating responses coming from your application actually is a better approach. Security and privacy is a big concern, of course. Some customers super concerned about sending any data to the cloud, especially like there was a leakage. The Samsung employees sent out designs to ChatGPT, and the ChatGPT, OpenAI, incorporated it into the model. And on AWS, your data is not used for training underlying models. That's your data. We cannot respect that. Data is encrypted in transit and at rest. Data APIs stay in the region. They're not doing cross-region if sovereignty of the data is important. And then there's support for FedRAMP, GDPR, et cetera. Let's just quickly look at some of the applications here. So this is a Streamlit-based application with Bedrock. Actually, right after this meeting, we have a lab where you will be building this specific application, and the non-production version of this application. So if you want to stop by, it's something Mezzanine 5 and 7. It's a hands-on activity. You need to bring your laptop. So you'll be building this application and interact. I mean, building. The code is pre-built. You just need to connect the pieces and run it, and then you can play with it. So in this particular application, we're using Titan embeddings to create embeddings. That's a Bedrock model. I think I used Text Express. That's another model to do responses, to actually, based on the prompt, to respond. For compute, here I didn't choose Lambda. I used Fargate. And Streamlit runs on WebSockets, so I had to put in a load balancer in front of it. But this kind of architectures will scale. MongoDB Atlas will scale. Fargate will scale. Because this is production, I put private link there, because customers don't want data traveling over the internet. So in this case, connection to Atlas goes over, it's private. It stays within the AWS. Nobody can see it except for you. And yeah, and we'll have a simplified version of this application, but this is kind of production. Oh yeah, we use, of course, Secrets Manager to store the secrets, and Fargate runs on top of ECS. In this case, you can customize your prompt. I mean, there's code. And then some kind of general guidance in terms of like how complex things are. Prompt engineering is the easiest. And low complexity, quality maybe, but you may need to spend more time constructing these prompts to get the quality you want. Cost. It's very cheap. Prompt changes are very, very cheap. So retrieval augmented generation is next best thing. But it comes with a little bit of more engineering work. Prompt engineering, actually, any grandmother can do it, or grandfather, or dog. Once you get into RAG, it has to be software engineering because you're calling APIs, you're coding. Fine-tuning, still kind of, fine-tuning, continuous pre-training, you might need to get data scientists involved. Actually, like on the next slide. Yeah, so this is similar, but in terms of costs, prompt engineering is the cheapest. Retraining the model from scratch is the most expensive. Like Llama, I think Llama model training costs in the order of $1 million in compute. So most likely you're not going to do it, or if you do it, you will be much smaller model. And there's some in-between options. So retrieval augmented generation is like the most balanced approach. People kind of stay with it. In terms of skills, I said your dog can do prompt engineering, but there are some sophisticated techniques, actually. I shouldn't say it. RAG is primarily data engineering. Fine-tune, you need some machine learning kind of things. ML ops are needed. You need to track the model performance. Traditional, you need to track the metrics, which data set went into the model. It's traditional data scientist stuff. And build your own from scratch, it's like that, but on steroids. You also, on top of that, you need to have access to large amounts of data because all of the LLM providers basically scraped everything they can get their hands on legally or illegally. And that's what's in their models. If you want to get started, there's some QR codes. But there's a code to the workshop if you want to do it yourself. Otherwise, come to the next session, and we can do it together with a hands-on keyboard. I don't know if anybody has any questions. Otherwise,
thank you, Igor. Is there any question?
Oh, thank you.
That was very good. I think we have time for a couple of questions.
We have time, yay.
Yeah. Question, anyone? No? All good? Okay, I'll see you to the next session.
Oh, well, I have to ask AV people why the screens are slow. Streamlit. Oh, why Streamlit? It was an easy to use framework.